Good morning everyone. Today let us see a video presentation on central lathe, its construction and working principle. I am Dr. N.J. Vignesh, Assistant Professor from the Department of Mechanical Engineering, SRM Madurai College for Engineering and Technology, Pottapalayam, Sivaganga District. With this short introduction, let us directly move on to the actual construction and working. Okay, what is mean by a lathe? A lathe is nothing but it is a machine which is used for removing metal from the workpiece. Actually, a lathe works on removal of material for generating a particular workpiece or product. Okay, there are different methods of manufacturing. This lathe comes under subtracting process. Actually, we are having addition process, subtraction process for manufacturing any metallic component. For example, casting is an addition process wherein which there is a mold cavity and we are having molten metal. When this molten metal is poured into this mold, you will be getting the desired output shape. Okay, there we are adding a metal into a particular mold. But in case of subtractive process, such as in case of lathe machines, we are having something called as billet, which is a larger size of the actual product which we require to manufacture. Okay, initially the size and shape of the raw material will be very large when compared to the actual final output that we desire. So using this lathe machines, we need to remove the material in a stage by stage, step by step process, so that we will be able to get the final output. Okay, so this lathe comes under subtractive process of manufacturing. So this lathe is a machine which removes the metal from workpiece to the required shape and size. It is one of the most important machine tools in metalworking industry. A lathe operates on the principle of rotating workpiece and a fixed cutting tool. So here if we see a lathe machine, it will be having a headstock spindle, and the spindle will be carrying the actual raw material where we will be inserting any metal which we desire, and there is a tool post. On to this tool post we will be fixing the tool, which is usually a single point cutting tool. So your spindle will be allowed to rotate at the desired speed, and when this single point cutting tool is made to contact this rotating workpiece, then metal will be removed. Okay, this is the basic idea of the lathe working machine. Now let us see one by one. The cutting tool is feed into the workpiece, which rotates about its own axis, causing the workpiece to be formed to the desired shape. Okay, this is the thing which I have explained. Let us see it in the diagram later on. Lathe machine is also known as the mother or father of the entire tool family. Okay, so we see that lathe is the primary machine or the important machine which is used to form any kind of desired product. Okay, therefore it is also said to be called as the mother or father of the entire tool family. So the father of this lathe machine is Henry Maudsley. Okay, so he was born on an isolated farm near Giggleswick in North Yorkshire and educated at University College London. Okay, he did his education in University College London. He was an outstanding student, collecting 10 gold medals with an MD degree in 1857. So this is the person who invented the lathe machines. Based on his invention only, we are able to develop so many different types of lathe machines like automatic lathe, Swiss type lathe, capstan and turret lathe, etc., etc. Okay, so he is the father of this invention. So functions of lathe. Lathe is used to remove excess material in the form of chips by rotating the workpiece against a stationary cutting tool. So there is a cutting tool which is fixed onto the tool post, and when this cutting tool is allowed to come in contact with the high speed rotating workpiece, then it results in the gradual removal of materials in the form of small bits of chips. Okay, these chips may be continuous chips or tiny bits of chips. Okay, this is happening. Okay, because of this contact. Okay, so industrial revolution it demanded more production, more precision, changes in manufacturing processes, and it also lead to the development of high speed, okay, special purpose lathes. So what it is given here is that as the countries are moving towards rapid industrialization, they require the production to be increased. In order to increase the production, they require machines which are able to manufacture components within a short period of time with good quality and precision. Okay, so that can be done by using these lathe machines. So this development of this lathe transformed the entire industry into a modern world. Okay, so it also led to changes in manufacturing processes. It also lead to development of high speed equipments, and using this central lathe they have also developed some special purpose lathes. Okay, so the following slide indicates the main components of a central lathe. So it includes bed, headstock, tailstock and carriage. Okay, we can see it later on in detail. So this is the diagram of a modern lathe machine. So you can see that here various components are shown. Okay, so on the left hand side of this diagram you can see there is a headstock. Okay, this portion is said to be called as headstock. Inside this headstock we are having so many number of speed gear trains. Okay, this gear trains are used to vary the speed of this chuck. So this is called as chuck. There are various different types of chucks. There are 4-jaw chucks, 3-jaw self-centering chuck, magnetic chuck, etc., etc. Okay, so this chuck is the place where we will be inserting the inserting the raw material. Okay, it may be cylindrical or even some square shaped materials can also be inserted. Okay, so this is the chuck, and this particular portion is said to be called as carriage. Okay, so this particular portion is called as carriage. This carriage is sliding on something called as lathe bed. So you can see that this is the lathe bed. Okay, this lathe bed is having very good surface finish. Because of that this carriage is able to slide very easily. Okay, so onto this carriage we are having some other arrangements like apron. So an apron is nothing but it is a housing which is used to house the gear trains. Okay, then there is a lead screw which is attached here, and there is a lock nut which is provided. Okay, this lock nut or split nut, whenever you are engaging this split nut with this lead screw, what happens is that your carriage post will be moving automatically. Okay, we can automate the movement of this carriage by using this split nut when it is engaged with your lead screw. But if it is disengaged, we can move this carriage manually by rotating this hand wheel. Okay, there is a hand wheel which is available here. Then at the top of this apron we are having something called as saddle, which is hutch shaped. When we see it in the top view, it is hutch like shape. Okay, the cross section will be hutch like something. Okay, then there is called as cross slide. Cross slide is a portion where we can move your this tool post from front and back. Okay, actually your carriage will be used to move this entire tool post from left to right, but this cross slide is used to move your tool post from front and back. Okay, so that is a function of this cross slide. And on top of this we are having compound rest. So this compound rest is a place where your tool post is inserted. Tool post is the place where we will be inserting the single point cutting tool. Okay, so this is about the constructional features of your carriage. Then behind this carriage we are having tailstock. A tailstock is used to machine larger cylindrical workpieces like lengthier shafts. Okay, so this tailstock, it can slide over the surface of this lathe bed, and it is having a lock nut or lock screw to fix this tailstock at any convenient position. Okay, and at the top of this tailstock we are having a hand wheel. So whenever we are rotating this hand wheel, the tailstock chamber or the tailstock spindle will be coming out or it will be going in, and onto this tailstock spindle we are having a dead center. Okay, this dead center is used to fix or handle larger shafts onto it. Okay, so this is about your tailstock, and the entire body of your lathe, which is located at the bottom, it is made up of rigid cast iron. Okay, this rigid cast iron is used to hold this entire lathe body, and it also helps in preventing any vibrations or any shocks which are coming while turning your workpieces. Okay, so that is transmitted directly to the ground. So on both the ends of this lathe body there are some clamp screws. Okay, these clamp screws are used to clamp this lathe lathe body onto the floor onto which this lathe is attached. And coming back to the headstock, this headstock will be having different mechanisms of gear trains. Okay, the gear trains are provided in such a way that we can vary the speed of the spindle as per our requirement. Okay, so there is a spindle speed selector which is available here. By adjusting the spindle speed selector, we can vary the or we can select the speed. Okay, so this is about the brief overview of your central lathe. Now let us move on to the next slide. So this particular diagram shows a simple line sketch of a lathe. So on either ends of the body we are having column. Okay, column is nothing but it is a support structure to hold this entire lathe bed. Okay, onto this lathe bed we are having headstock. Okay, headstock, it is having the gearbox or gear trains. Then we are also having something called as feed box. So this feed box is the box which is getting its power from an external electrical motor. Both this headstock and feed box are getting power from the external electrical motor, and this feed box in turn it transmits the power to the feed rod. Okay, it transmits its power to the feed rod. So previously we have seen something called a split nut here. Whenever the split nut is engaged, what will happen? Your feed rod will be able to move the carriage automatically with the help of this lead screw. There is a lead screw here. Okay, with the help of this lead screw and this feed rod, your carriage will be moving automatically. Okay, then at the center of this chuck, it is said to be called as live center, and opposite to this we are having tailstock, which is called as dead center. Why it is called as dead center? Because this particular center will not be rotating, it will be static in condition. Okay, but your live center, it will be rotating because it is a place where we are fixing our workpiece. Okay, so onto the tool post we will be connecting the tool. So various parts of a lathe, it is having a lathe bed, headstock, quick change gearbox. Okay, this quick change gearbox is nothing but it is a gearbox which is used to vary the speed of your chuck, okay, or spindle. Then there is a carriage which is used to move your tool post from one location to the another. And we are having cross slide which is used to move your tool post front and back. Then there is an apron which carries the gear arrangement to connect your carriage for moving automatically with the help of lock nut. Okay, then there is a tailstock, then automatic feed lever, then feed of an engine lathe. Okay, we have seen something called as feed box mechanism, and shear pins and slip clutches. Okay, these are all the various components. Now let us see one by one. So before going into the detailed explanation of each and every individual component, let us see a brief working principle of the lathe. Okay, so here you can see that there is a support available here. Okay, so this support is nothing but it is a chuck. Okay, So this chuck also rotates along with your workpiece. This is your job or workpiece. Okay, it is connected to the chuck, and this support, it is nothing but it is your dead center of your tail stack. So this is your live center and this is your dead center. So live center in turn, the support will also rotates along with your workpiece. Okay, but this never rotates. This is just a mechanism for supporting this lengthier job without falling. Then you can see that there is a tool. Whenever your tool is moved from one end to the other by slowly contacting the tip of this workpiece, what will happen? As it rotates, it slowly removes the workpiece. Okay, this is the basic principle behind working of any lathe. And if the tool moves parallel to the workpiece, cylindrical surfaces form. You can see. So initially the diameter of this workpiece is, let us take, this is capital D. I need to convert this capital D to small d. Okay, so I am giving some depth of cut. This particular height, okay, the height which is available here, it is called as depth of cut. This particular height, okay, this height is said to be called as depth of cut. So I am giving a certain depth of cut. Actually, you are seeing that here the depth of cut is very large, but practically we cannot give such a large depth of cut. So it is expanded. Okay, for your easier understanding purposes, they have expanded this particular portion. So it will be in few millimeters. Okay, very small, 0.5 mm or 1 mm like that. Okay, so whenever I am giving some feed inwards, what will happen? The diameter, which is initially capital D here, will get converted into small d. So this is the basic working principle behind the lathe. So this will be rotating and this will be moving from right to left. Okay, this is called as tool feed. This is your speed and this is your depth of cut. These three are the very essential and important parameters which defines the final output and quality of your workpiece which is formed. Okay, speed, feed and depth of cut forms the important factors or parameters which defines the final quality and surface finish of the final output which is formed. Okay. The next one, for taper jobs, for machining taper surfaces, what we will be doing, we will be rotating the tool post at a certain angle, or we will be rotating the compounders. Okay, there is something called as compounders swivel, and based upon the angular requirement, there is a calculation for finding out the angle required for machining this taper job. And if this compounders is tilted to that particular angle, we will be able to produce a tapered job. Okay, previously you can see that the surface is parallel to the surface of your actual workpiece, but here the surface is taper to the axis of your actual workpiece. Okay, so these are all the various methods of machining using a lathe. Then working principle. So it initially holds the between two supports called centers. Chuck or face plate is also used for holding the workpiece. Okay, so predominantly we will be using the chuck for holding. Face plate is an additional arrangement, we can see it later on. Cutting tool is held and supported on a tool post. Movement of the job is rotating about the spindle axis. Tool is feed against the workpiece. Okay, so this rotating workpiece as well as the movement of your tool, both will lead to removal of the workpiece in the form of chips. Okay, now let us see the various components in detail. First one, lathe bed. Okay, so this is the heavy rugged casting which is made to support the working parts of the lathe and also guide and align major parts of the lathe. So you can see that there is a triangular shaped knife edge. Okay, onto this knife edge your tailstock and your carriage will be moving from one end to the other in a linear fashion. Okay, so this entire structure is made up of casting, and the top surface of this lathe bed is having very good surface finish. Okay, because If the surface finish is poor, and it will lead to wear and tear of this lathe bed, therefore there will be improper movement, or the movement will be stopped. Okay. So it is also very essential for the lathe workman to frequently clean the surface of this lathe bed, okay, because whenever we are machining any workpiece, then there will be chips or burrs which are formed, okay. So that will lead to create any wear and tear on the surface of this lathe bed. So this is also made up of cast iron, and the top surface is machined to very good surface finish, okay. It should be rugged and strong enough to hold your tailstock as well as your carriage, okay. So this is the first and foremost component. The next one is headstock. So this particular portion is called as headstock. Your headstock is a area where it houses your gear train mechanism. Onto the gear train mechanism there is a spindle which is connected. Onto the spindle we are having a chuck, okay. The chuck may be different type, it may be 4-jaw chuck, 3-jaw self-centering chuck, magnetic chuck, pneumatic chuck, etc., etc., okay. Some special types of jigs and fixtures can also be connected onto this chuck in order to facilitate special type of machining, okay. So you can see that there are some levers which are used to vary the speed of rotation of this particular lathe head spindle. So the headstock houses the main spindle, speed change mechanism and changing gears. The headstock is required to be made as robust as possible due to the cutting forces involved, which can distort a lightly built housing. So what they are insisting here is that if your headstock is not made to sufficient rigid support, or it is not having sufficient strength, then it will lead to easier distortion, because large amount of cutting forces and vibrations are taking place whenever your tool post or your tool comes in contact with the workpiece. So all those forces must be withstand by this headstock, okay. So this headstock should be made very rigid. The next one is quick change gear mechanism. So this, it contains number of different sized gears, provides feed rod and lead screw with various speeds for turning and thread cutting operations, okay. Usually we will be engaging the lead screw for thread cutting operations, and there is also a feed rod, okay. This feed rod is a rod which is used to provide power to your carriage. So you can see different sets of gear trains are available. If we engage a particular gear with another larger gear, we will be having a particular speed. For example, if we engage a smaller gear with a larger gear, then the torque will be higher but the speed will be lower. But on the other hand, if a larger gear is engaged with a smaller gear as output, then the speed will be higher but the torque will be minimum, okay. That is the basic principle. So the arrangement which are employed in feed gear boxes to obtain multiple spindles, speeds and different rates of feeds include sliding gear mechanism, sliding clutch mechanism, gear cone and tumbler gear mechanism, sliding key mechanism, combination of any two or more of the above, okay. So these mechanisms are the ways in which we are providing speed to your gear trains or gear boxes, okay. So what they have indicated that a particular type of lathe may have, for example, sliding gear mechanism to vary the speed, or sliding clutch mechanism to vary the speed, or combination of any one of the two, okay, or more than two, for providing the desired output. So next one is carriage. So carriage is used to move the cutting tool along the lathe bed, okay. It consists of three main parts. They are saddle, cross slide and apron. So as you can see from this diagram, this is your apron. So inside this apron we will be having some gear arrangement which is used to engage or disengage those gears to provide feed to this carriage to move from right to left. Okay, so we are having a carriage spindle. Okay, we are having saddle. Okay, the saddle is actually hutch shaped. Why it is called as hutch shaped means because one part of the hutch is available on one end of your lathe bed and another end of the hutch is available on the other end of the lathe bed, and both of them are connected by a bridge like arrangement. Therefore it will be looking like a hutch shape from the top. Then we are having cross slide. So this cross slide is used to move your tool from front to back. Okay, from this end to this end. Okay, or in other words it can be said to be called as transverse movement. Transverse movement of your tool is possible only by means of this cross slide. Then there is a compound rest. At the top of this compound rest we are having tool post. Okay, so these are all the various components which are available in a carriage. And one more thing to be noted here is that here we are having a lock nut. Whenever this lock nut is engaged, your carriage will start moving automatically by using the feed mechanism. Okay, or we can also move this carriage manually by rotating this hand wheel. So this hand wheel is used to move your cross slide and this handle is used to move your compound rest. Okay, then cross slide. So this cross slide is mounted on the top of the saddle. It provides manual or automatic cross movement for cutting tool. Okay, so this is your cross slide. You can see that by rotating this cross slide, this is your cross slide, this is your compound rest. Okay, this is compound rest, this is your cross slide. By revolving this handle, your cross slide will be moving transverse direction. In some lathes you can also see there is a coolant supply. So the purpose of this coolant supply is to minimize the frictional heat which is generated in between the rotating workpiece and your single point cutting tool. You can very clearly see the single point cutting tool available here. Okay, and one more thing I need to mention here is that the tool which is used here should be having hardness higher than that of the workpiece which is used, because if the workpiece is having higher hardness when compared to the tool, then the tool will become blunt or it may broke. Okay, so it is very essential that the hardness of your tool should be greater than the hardness of your workpiece which has to be machined. Next one, apron. So apron we have already explained. So it houses gear mechanisms required to move the carriage or cross slide automatically. I have mentioned you previously. So there is a automatic feed lever. Okay, whenever you are engaging this feed lever, what will happen? This entire carriage will be moving in a longitudinal direction from right to left. Okay. Locking of lever inside the apron prevents engaging split nut lever and automatic feed lever at the same time. Okay, apron hand wheel may be turned manually to move the carriage along the lathe bed. By using this rotating this hand wheel also you can move your lathe carriage from one end to the other. Last one, tailstock. So it is having upper and lower tailstock castings. Okay, what is mean by upper and lower tailstock casting? This particular portion is called as lower tailstock casting and this is called as upper tailstock casting. Both of them are connected together and it is adjusted for taper or parallel turning by two screws set in base. Okay, there are two screws which are provided here. By adjusting this clamp screw we can move your tailstock from one end of the lathe bed to the other end. Okay, so that is explained here. It is used to provide support for machining longer or lengthier work pieces, and in case of taper turning also it is very helpful. Okay, tailstock clamp locks the tailstock in any position along the bed of the lathe. Tailstock spindle has internal taper to receive dead center. Okay, so there is a spindle and this is your dead center. This dead center is a taper in shape. and the internal of the spindle is also taper, so in order to engage your dead center. So it also provides support for right hand end of the work. So specifications of a lathe. The lathe can be specified based upon the following different conditions. You can specify a lathe by length of the bed which is required, maximum distance between the dead center and live center, that is in between the tool live stock and dead stock, and type of bed. The type of bed, it may be straight, semi gap or gap type, height of the center from the bed, swing over the bed, swing over the cross slide, width of the bed, spindle bore and spindle speed. Okay, with this brief introduction, we are coming to the end of the central lathe. I hope you have enjoyed this video. Thank you very much.